My pleasure. So, this is a good start. I mean, aviation is a key enabler for global society that we enjoy and live in today. But additionally, sustainability is one of the most important issues that society needs to deal with today. So it's no surprise that both safety and sustainability are at the heart of everything that we're doing at Airbus. Over the next 15 minutes, I'm going to answer the question, to be a truly sustainable, what technologies or innovations do we need? So, as I say, my name's Mark Bentall. I head operations for Airbus Technology. And these are the 6 areas that I'm going to be talking through briefly today. Most people, or a lot of people outside of the industry, might simply think that we need to put a hybrid electric aircraft in the air, and whilst fundamentally and massively challenging alone, that is not enough. We have to address more than that, otherwise we will fail. And so I want to put a little bit of context to what that means. If you look, to set the scene, if you look at the left-hand side, you will see that not only are we, this is compared to 2019, over the next 20 years in the commercial aviation sector, so that's things larger than 100 seats, it's a 4.3% per annum growth. And this is really driven because the urban growth is driving, and it's a global society, and we're seeing new routes being created quicker than those routes that are being cancelled, which actually results in 39,200 aircraft, new aircraft, to be in service within the next 20 years. Today, there are 23,000 aircraft in service, and about 8,000 of those will still be in service by the time of 2038. And to put that into context on the, and in addition to that, that's going to result in some additional 526,000 new pilots. So today there are about 200,000 pilots operating today, and obviously through attrition, that will need to be replaced, and we have more pilot demands. So that's the industrial context. If I then add on to that the environmental context, the aviation industry has already set some pretty tough ambitions in this area over the past years. We've already set an environmental ambition that we've signed up to for 75% CO2 reduction, 90% NOx reduction, but also important for aviation is 65% noise reduction, and that's compared to 2000. And these are self-imposed targets, but we've also got a pretty good track record so far. In the last 70 years, we've had a 70% reduction in CO2, and 53% of that has come in the last 30 years. So we've got a good track record, but remembering that the technology to come has got to achieve a lot of that. So what is that technology? First of all, we start with electrification. So with electrification, yes, it's one of the key enabling technologies to achieve environmental sustainability. But it has to unlock a lot more than that. Not only does electrification bring more challenges because it's not necessarily going to be the most energy efficient form, we've also got to look at different configurations. Our aircraft today are optimized around gas turbine technology, and now we have to find a new optimum, which will be based around electric and hybrid electric technology. That means that we have to look at new things like new configurations, and you see some new designs with things like boundary layer ingestion, distributed propulsion that we have to address. And you don't just see it in the commercial aviation in the large sector, you also see a heavy push coming from the urban air mobility sector as well, where electrification is absolutely a must. But for commercial aviation, we're a little bit different in that, because whilst in automotive, we have vehicles in the range of 100 kilowatts, and in maybe urban air mobility, we're less than megawatts. In the commercial aviation, we're in the multi-megawatt region in order to achieve flight, probably somewhere in the region of 5 to 10 megawatts. And nobody yet has built a multi-megawatt electric aircraft, so there's a lot to learn. And we've created a first program called EFAN-X, which is our multi-megawatt demonstrator. We're going for 2 megawatts. It's a 2-megawatt electrical motor, 2 megawatts of battery power, but obviously to sustain that, we still need a thermal engine today. We've got lots to learn on the thermal, on the high voltage. We're running at 3 kilovolts in order to minimize weight. We've got new weight and load distribution challenges to manage. We've got new energy management. And we're doing this with partners Rolls-Royce. And we're reconfiguring a BA146. In addition to that and the platform to learn, we need somewhere to test it on ground before we go fly. So we've also created a e-system house in Munich, which has the ability to combine turbo machines and electrical systems for two full 20 megawatt generator sets. So there's a huge amount to be addressed in the electrification area. I mentioned pilots, and we need to reimagine piloting. It's not going to be safe for us to assume that we can achieve that number of pilots. So we need to reimagine how we're going to achieve that. And it's more than just what we would call a glass cockpit, which is digitizing what the displays and controls are today. We've got a progressive approach that we use, and we actually apply this across a number of different platforms in different phases to achieve this evolution, starting with things like pilot assistance, single pilot, mission focused. This is something that's been used in the military domain for many years. We need more automation. The urban air mobility air taxi market is certainly pushing ahead strongly on that one. Features certain phases of flight like taxi, takeoff and landing that can be highly automated, and obviously learning more and more about autonomy with unmanned systems, again, something already done in the military context. This leads to more radical layouts, displays, information, but it's a total approach that we're taking to look at the training needs of the pilots as well. So autonomy gives us also additional features for environmental topics because we can start to improve flight path optimization and efficient piloting to achieve our sustainability targets. Connectivity. I think we all understand the importance of connectivity today. We wouldn't be without it. There's three main focus areas for us on connectivity. First of all, the flight systems themselves. We can do improved optimized flight path management, which contributes to environmental sustainability, as well as we can additionally add extra sensors and capabilities to the aircraft to improve the ATC view of the world. Flight operations, we see a heavy demand of more data to maintain the flight or the in-service time of the aircraft throughout the day. We've already gone from about an 8-hour availability per day to 10 hours, and this is something that also needs to grow. And finally, the passengers, us, we have an insatiable demand for connectivity and bandwidth, and we all expect an at-home-like experience when we're on the airplane. So what are we doing? We work very closely with across Airbus and across the space industry as well. We're working with and on very high throughput geostationary satellites to get the high bandwidth demands, massive constellations of low Earth orbit satellites, dynamic inter-satellite air-ground systems. We're also promoting the use of mobile spectrum at the WRC-19 World Radio Conference this year. Improved safety critical SATCOM, flat panel displays. One of those little domes on top of the airplane today is the equivalent of about 4 passengers worth of weight, and a lot of in-service software upgrades. So connectivity is an underpinning capability to achieve sustainability. Artificial intelligence, instantly people think about autonomy and how artificial intelligence can contribute to that, and for sure, we need to work and understand that. First of all, we're trying to explain how it works, so we can then learn how to trust it, and then finally how to certify it. But it's much more also for us. It plays a major role across the whole industrial chain, everything from design and manufacturing, real-time maintenance and maintenance prediction. We use it a lot in computer vision. We use it also in flight assistance, where we're already looking at deploying something like speech-to-text for air traffic control command, so the pilot has an instant readout of everything that's gone before. So artificial intelligence is an enabler for more efficient manufacturing and improving aircraft operation and utilization. Industrial. So I mentioned the number of aircraft. Now, currently, Airbus and Boeing is 50-50 split market share, so 39,000 aircraft in 20 years. If you do a few sums, that's 80 aircraft a month that have to be produced, which is not far off where we are today. However, we must make sure that we maintain that. And very typically, in our research of the past, we focused very much on performance of the weight, performance of the aerodynamics. And now we've included into our full research roadmap the manufacturing and production and assembly for rate as part of our program. And there's a number of topics. We're never at the rate of automotive. This is not even a day's production for automotive. But we're talking about digitalization of the full life cycle, every aircraft having a full digital twin throughout its life, printing the paint on the aircraft instead of painting the aircraft, hole-to-hole drilling for large structures where you have to take into account all the deformation of the structures before you can do it, robotic assistance and environmental sustainability with reduced waste and reduced energy. So we are designing our technologies and processes for industrialization, which will allow us to deliver the growth and manufacture in a more environmentally sustainable way. Then on to advanced materials. So what I said earlier is that we have, with a hybrid electric and these concepts, we're actually going to be probably more energy inefficient. Although we'll be clean, it'll be more energy inefficient. So we need to compensate for that. We can compensate for it aerodynamically, as I've said, but we also need to compensate for it in other ways. We need new materials. We need new materials to address things like weight. We need new materials to address things like volume, but we also need new materials to address topics such as thermal management and some of the thermal challenges that these new propulsion systems will give us. We need lower energy for manufacturing. We need to reduce waste in our materials and our processes, and we need to improve on the recyclability. All of these things are considered in our materials programs, in our industrialization programs, in our flight structures, flight physics programs. Some of the technologies, certified printed structures using new alloys or rapid deposition rates for hard alloys, out of autoclave materials for low energy, reduced waste and reduced energy, or more elaborate, and we have some quite more extreme programs looking at things like spider silk and the thermal properties of carbon nanotubes. So in order to compensate for the technological challenges and advanced materials are going to be required to balance our weight, thermal, and volume challenges in the aircraft of the future. So in conclusion, sustainability is going to be a combination of needs and is bringing a new era of an exciting era of aviation. It's a fantastic time to be in this industry. Our engineers, those in our ecosystem, amaze me every day with the new solutions and the new ideas. Our knowledge is growing at an immense rate as we go through these programs and more. This is not the full complement of technologies, it's just the ones that we've highlighted. Our 2050 target are really challenging, but I'm confident that we will make it happen. Thank you.